Okay, so last class we saw basic simple linear regression. Now let us represent it in form of equation. Okay, see, this is what happens in regressions. Okay, this is what we had done last week. Okay, so last class, simple linear regression. So what is this thing? This is the equation of a straight line. Okay, how do you represent a straight line? If there's a straight line, okay, or this line or this line. So this is that equation of the straight line. Okay, now this will consider only one variable x1. Okay, simple linear regression. It will consider only one variable, simple linear regression. If there are multiple variables like x1, x2, x3, x4, if y is dependent on multiple variables, the case like this, then we have to do multiple linear regression. Okay, let us consider a data, this data. Okay, now e is dependent on all these four variables. Okay, this output pe is dependent on all four variables. We don't know which variable is having more impact. Okay, so either we can sit and observe manually, or we can consider applying a multiple linear regression. It will which will automatically take care of all these things. Okay, and it will give the values which is have which particular case having more significance. Okay, so let us see that data set now. Okay, so this is the data set for 50 startups. Okay, 50 startups. So there are 50 50 companies. Okay, 50 companies are there. These are basically 50 startups which are there, and this is their profit. Okay, and this is the profit, and this is the amount they have spent in R&D, research and development. They have spent that this much administration to take care of management, events and all, marketing, to spread information about this, advertisement, giving amount to film stars, all those things. State, which is from which state they are operating. So see, for example, in India, Karnataka, so different states where they are operating. Okay, that is this data set. Okay, what I want you guys to try is use this 50 startups and see and apply linear regression, simple linear regression. Try to apply and see how it will work. Okay, first I will share the data set. I am going to share one data set. See what you have to do. This is your profit. Finally, we are interested in profit. You have to just try to apply one versus one. Okay, just see how strongly profit is dependent on R&D, how strongly profit is dependent on administration, how strong profit is dependent on marketing. Okay, then how strong state you cannot do because this is in strings. I will tell you how to do that. Okay, so just try to do some plots. So what is the change in the code you have to do? I will tell you. Come to simple linear regression. Instead of data, you have to represent this with our name, 50 underscore startups. That is the first change. Then there is no other change. Okay, you can just you have to change this value one by one. Okay, and then you will be able to do it. Everything else will be same. You have to just play with these two lines. That's it. Then you can see the outputs and see how well it is dependent. So quickly in say 3 minutes you can try. Then I will show you the other steps. Okay, in multiple linear regression. Okay, so let me show you. So I have to first let us go to simple linear. I'll show you that in the multiple linear regression only. Okay, so here, what is this step? I am considering all the values, okay, except the last column. Except the last column, I am accepting all values. Okay. In your case, you have to consider one by one each values. Okay. Second step, I am accepting only the last column here. What does this do? It will take the last column of the data. Here, except the last column, it will consider all the columns. So what will be the value of x? We will see once. Okay. Okay. So what is this? So this is these four columns. Okay. If you see carefully, see this 1653, 1368, 4717, 1653, 1368, 4717, and New York. So this is considering all the columns except the last column, which is the profit. Okay. Profit is in Y. If you see Y, it will have profit. Okay. So one more important thing you should observe here is in the output. This one is falling in two brackets. There are two square brackets. Okay. It is not a single pair of brackets. Here there is two pairs. That what is that says? It says it's a two-dimensional data. Okay. If you see Y, it will be one-dimensional data. So these are the things which you must observe carefully. Okay, Y X is two-dimensional, Y is single dimension. Okay, so these are the question you must have in your brain. Okay, next step. What is this? This is a method to convert our strings. If there are any strings in our data, we will know. See, for example, if there is a land, okay, and few of you are from Mangalore, okay. If a land is purchased from Hampanghatta, that will have more value compared to a land in some remote place in Suratkal or Kaikamba. So there will be difference. So you know that land purchased in Hampanghatta has value. I know that land purchased in Hampanghatta has more value, but Python will not understand that. Okay. So Python we cannot understand Kaikamba and Suratkal. Okay, it can understand numbers 1, 2, 3, 4, but it cannot understand strings. So Python, what we should provide Python is a number for that. Okay. So here what we will do, we will convert the strings which are there in terms of numbers. How we will do that? Let us see. So the lines which are used to do it is these three lines. Okay. So here we are telling encode using one hot encoder column number 3. Why column number 3? 0, 1, 2, and 3. So we are telling by algorithm which will use sklearn column transformer to encode them, encode the numbers column number 3. Okay. Now what it will give we will see. First how it will encode I will explain. Okay. So here there are this is state, right? So what it will do is this particular column it will convert it into example what it will do New York. I will write shortcut California, Florida, and if you see other names are repeating New York, Florida, New York, California, Florida, these are repeating. So what it will do wherever New York is there it will make 1, California is 0 here, Florida is 0 here. Next case California is 1, so New York is 0, yes, 0. Next Florida 0, 0, 1. Okay. Next like that it will continue. Okay. New York, all these things it will continue. And this is how you can this is how it will convert your actual data which you are having 4 columns into 3 plus 3 6 columns. So 4 column data has now become 6 column. Okay. Now let us see how it has converted. Let us go back and see this. Let me print text. Okay, so this is that extra columns which it has added. Okay, other three columns will remain as it is. So this was the previous data where this New York was there. Now it has converted that into this form. Okay, now it will, it knows there is a column called New York, column called California, and column for this. So that it knows, which one Python knows about it. Now, okay, now our task is over. Now this particular thing is exactly similar to simple linear regression. Okay, so what was the one step extra? This step from multiple linear regression, there is one change step, one small change here. Then this is required only if there was a string. Okay, if there was no California, no state information was not there, you need not do this particular column. Okay, then here splitting data set into training set and test set. So this is exactly same like it was done in the previous simple linear regression. Next step is also same. Okay, now in our this phrase, plotting we cannot do. Why we cannot do plotting is the plotting will not make sense because we cannot plot basically more than one data. Okay, so if there are more than one column in x, if there are more than one columns, we cannot plot it. We can only see the result in terms of numbers. So what we do here is we take ypred regressor dot predict and x test. What is this regressor dot predict x test? This is the test data that we have used in this, and we are predicting the output. Okay, and np set print option precision and is equal to code 2, and uh, this is just to see the precision, and here we are printing the expected value and the actual value. Okay, and we are running it. Okay, I'll just see whether what was the state I had stopped for. Okay, this is simple linear regression. Now I okay. Okay, so yes, we have seen. So yesterday's code only. So here till here it is yesterday's code. What is this three line? Now instead of uh, seeing the data in terms of plot, here we are seeing the result in terms of number. What is that? We'll see one. Okay, so this is your, see what is this final, this is your final result. Okay, this is your final result. What does that say? It is saying that this is the predicted value by your machine learning, and this is the actual data. Okay, so you can see it is almost close by, this is almost close by, this is close by, this is close by. So this is saying that, so this is, there is some difference here. Okay, this is almost close by, so there is a difference here. Now you can see a difference here. So this says that in most of the cases we are almost close by to the result. Okay, now you can run this, try to understand this for some time, and for 10 minutes you under okay, so this will tell us the coefficient. Now what it has trained to, it has got trained to the following values. Okay, let me take it up here. Okay, so I had told you we have converted our 4 column data into 6 columns, 3 plus 3. Okay, R&D spend, administration, marketing, and that state. This is state. Okay, the first one, two, and three. These are three states. This is R&D. This is administration. This is marketing. Okay, so coefficient which has got the maximum value. So this is state. Okay, 8 e power 1. So this is very big. Okay, the states are also having lots of value. Okay, so this says that state is having good importance. Okay, mainly see, for example, if you start a business in Bangalore, it will generally click because it is whatever business you do there. There are people who will different kind of people will be there, and there is a very good chance that it will work. Similarly, next one is R&D spend. Okay, R&D spend is having also good value. So if you open a company in a very good state and with good R&D for that, it shows that it is having good success. Next is administration. How well you keep your people happy. Okay, if you are giving them good perks, there are good employees there. Okay, like that. So this coefficient, if you have, for example, if this equation, how it signifies, let me show you. See, if the value for this is small, when I tell small, it is like 0.001. This will be small thing. What is this? If it is 0.1, okay, it will be big. Or if this is 0.8, that means this particular column is having lot of dependency on this y. Okay, and this particular column in red is having less dependency. This is less dependency more, and it is this one is moderate dependency. Okay, this is high, this is moderate, this is low. Okay, that is how it is done. Okay, now I want you guys to try and see the uh, same thing for the yesterday's data which I have shared, data.csv. Now you have to apply multiple linear regression on data.csv and then see the output. So what is the difference between this data and this data? Or see, this data and this data only changes the state. So you need not apply one not encoder. You can just comment out these lines. Just comment it, and everything else will be the same. Okay, only this thing is this you have to change. Comment out this, and your code should work. Okay, then check how well it has matched. Okay, so I will not share anything for this. You can quickly see, then I will show you what is the same thing. Okay, try for 5 minutes, only 5 minutes you can try. Record. And if you come to insert and here, oh wait, it will not work like this. It has got stuck. Wait, take this insert thing we do. Okay, let me do the other plot then, 1 second. So I think, wait. So this is having that dependency. Okay, minus 1.97 is for this guy. Okay, for 80 it is minus 1.97. Okay, so what is that? 80, this one. Okay, least if we see, I think it is for this is somewhat it is there. I think least is for the third column. Okay, third column it is having the least. Let us see the third column. So what is third column? 80 V AP. Okay, AP, if I come and put here, you can see there is no dependency at all. even if it is changing. So see, as AP is changing, PE is not changing at all. Okay, it is almost constant. So as the coefficient has suggested here, the result. Okay, there is no dependency, and there was a very good dependency for this guy. Okay, then slight dependency for this, then again a slight dependency for this. So this is how you analyze data, and you can see here the matching is very close by. Okay, 431, 431, 458, 460, 462, 461. So here the multiple linear regression has matched the result very closely. Okay, hopefully you have understood this. Okay, yes, next one is polynomial linear regression. Okay, what is polynomial linear regression? So whatever we saw. Okay, so till now our relationship between data was like this. Okay, straight. The previous example, it was the data, it was like this, even it was a straight line. Okay, now what if the plot dependency is like this? Okay, initially it will be like this linear, then it will go exponential. Okay, that time your linear regression will not work. These two will not work. If you have something like this, you will need a new algorithm which is called as polynomial linear regression when you have exponential data. So what is an exponential data? Is a data where suddenly things are going to change. Okay, so for example, when you work hard, initially when you work hard, what you will see is slow response. Okay, you'll run. Then if you continue working hard, you'll suddenly see acceleration. Okay, this is called exponential growth. Okay, initially it will be slow. You will see that you will study, you will get something. You will study, you will get something. After some time, when you keep on putting that effort, then you don't have to put so much effort to get good gain. Okay, it will just grow exponential because many of them people will stop putting effort, and you will get, see, in your company, if you put effort, everyone will put effort, but after some point many of them are weak, they will not put effort. Then if you continue putting effort, you will start seeing wonderful gains. Okay, this is called exponential growth, which you can see after certain time. So initially it will be normal linear, then it will be exponential. Okay, now in order to do exponential, you cannot use the multiple linear regression. We will need something called as polynomial regression. Now let us see that. So this is our data and position salaries. We are going back to position salaries data set, and then here we are again using same linear regression. Okay, position salaries. Let us quickly see what is that. We have already seen it multiple times. Simple. Okay, these are the different positions in an office. Okay, if you are working in an office, you will be given some designation: business analyst, junior consultant. CEO is the maximum. So CEO will get this much salary, and others will get 43 to 45,000 salary. Okay, Okay. Now our case, we need this x1 will be passed as x1 square, like that it will be given. Okay. Now what we will do, we will try to apply polynomial feature. Okay. Polynomial feature degree equal to 4. So what is this degree equal to 4 means that we can go up to this x1 goes up to n. No, this n is equal to 4. Okay, n is equal to 4. Degree 4 means n equal to 4. So first we will take this data the way we were doing previously. Okay, then we will take this linear regression and we'll do this is simple linear regression. Okay, simple linear regression, just to compare difference between linear regression and simple linear regression, polynomial linear regression. Then we are setting this degree as 4. Okay, then we are doing polynomial dot regression dot fit transform x. So what will be the output of this? This will consider this will have x1 square, sorry, x1 square, x1 cube, x1 to the power 4. This will have that data. Okay, x is converted to x1 square, x1 cube, x1 power 4. If this n was 5, then it would have converted into x to the power 0, comma, x to the power 1, x to the power 2, x to the power 3, x to the power 4, x to the power 5. So this will have that data. Okay. Next next after this is exactly similar to your linear regression, simple linear regression or multiple linear regression. Everything is similar here. Okay, after this, now here linear underscore reg underscore 2, where linear regression is there. Okay, we are passing this x underscore poly. We cannot pass x linear regression x poly we are using, because so that we can give this x1 square, x1 cube to the data. Y is similar. Okay, after that everything is same. You can predict using this data, or you can plot. Why we are able to plot here? Because we are having a one dimensional data. Sorry, one column data. Okay, it is x versus y. If it was consisting multiple values, just like for data which we had multiple columns were there, then we cannot plot. Okay, plotting is you cannot do that. Okay, here x comma linear underscore reg underscore 2 dot predict, like that we can do, and we can plot it. Okay, let me show you this. Okay, so here you can see our earlier data, it will do this something like this. Okay, it will try to be, if you do linear regression it will do this, but if you do polynomial regression it will come and it will take this path. Okay, so there is a big change in salary here. Okay, so this big change can be adopted only by polynomial regression. So when to apply linear regression, when to apply polynomial regression, you must understand. Okay, so I will share this code. You guys can run this. You already have position salaries given, so I think you guys can try and run this. Position salary, oh, you have, right, the data set. I will check once. 50 startups I have given. polynomial regression you take. If you want, I'll reshare this also. Attach. I'm sharing position salaries also. Okay. So you guys can your assignment is understanding polynomial regression and applying. You should apply uh, data. The data there was another algorithm, no? This algorithm, and try to apply this in polynomial regression and see how it will perform. So you have to do certain changes in the code. You have to understand that, and let us see tomorrow or next tomorrow. Let us what we do is. Right now we'll not have class tomorrow, so you guys will have only 3 hours. Okay, so today I also have some work. We'll stop now, so we will meet on I think Tuesday. Okay, so no, Monday, right? I will tell you what was the batch. Wait. What we had planned was, okay, set the Tuesday. Okay, Saturday, Sunday also we sorry, tomorrow what we can do, 6:30 to 7:30. Tomorrow we will have, okay, sorry, tomorrow we'll have class. Yes. Tomorrow we'll have class. Okay, tomorrow we will meet, and tomorrow we'll see. Okay, so your task is apply polynomial regression into data, that data, and check. Okay.